In this lesson, we're going to walk through an example dealing with the standard or vertex form of a quadratic equation. So first we need to understand what the vertex form or standard form of a quadratic equation is, and that's f of x equals a times x minus h squared plus k. So part of the reason why it's sometimes called the vertex form is because we can easily identify what the vertex is just by looking at the equation. Your vertex, when it's in this form, is the numbers h and k. So when you have a quadratic equation in this form, a would be a number, sometimes it's 1, so it might not be written there, h would be a number, and k would be a number. When you're trying to identify the vertex from your equation, I like to think of it as you're taking the opposite of the inside. So we see that we have x minus h, but in our vertex form, when we find the vertex, we're going to have just a positive h. So when we walk through an example, I'll talk about it, how we have the opposite of the inside, but then we keep the number on the outside. So if it's a positive number on the outside, it would stay. If it was a negative number, it would stay. Your axis of symmetry is always x equals whatever your x coordinate of your vertex is. So when it's in vertex form, that means that the axis of symmetry would just be x equals h. Remember that when we're writing our axis of symmetry, it needs to be an equation, so it has to be x equals the number. If a is greater than 0, meaning that a is positive, the parabola would be facing upward. I like to say that he's happy. Positive means that he's happy. So he makes a happy face. If a is less than 0, which means that he's negative, it would be facing downward. So if it's negative, he's sad. He makes a sad face. The vertex then can be considered either a maximum or a minimum. If a is greater than 0, then the vertex is a minimum. And the reason for that is that if a is greater than 0, going back to the example that we just had, is that means that it's facing upward, which means that your vertex is the lowest point on the graph. Versus if a is less than 0, that means that a is negative. That means that the vertex is a maximum because, again, if we think of the picture, it's facing downward, so that vertex point would be the highest point on the graph, which means it would be at maximum value. So I'd like to think it through as I just walked through it, that if a is positive, that means it's going to be facing upward, and if it's facing upward, it's going to be a minimum. If a is negative, it's going to be facing downward, so by the picture we can see that it's going to be a maximum, because if you just think about the words of it, it might seem confusing that a is positive, but it's going to be a minimum, and a is negative, which means it's going to be a maximum. But if you walk through it step by step, it's probably easier to visualize. So now that we know what the standard or vertex form of a quadratic function is, now we can graph it when it's in this form. So first we want to be able to identify the vertex, again, since it should be fairly straightforward, not as much work as if we have it in ax squared plus bx plus c form. So again, our vertex is hk. And like I said before, is that really what you want to think of this as, that the h is the inside, but we're going to be taking the opposite of the inside. So that means that we're not going to have a negative 1, our vertex is going to be a positive 1. If there was a plus inside, you would make the number negative. And then the k would just be keeping the number on the outside. So it's a positive 9, so it's going to stay 9. So your vertex, not a lot of work, just understanding how to write it, would be the 0.19. Your axis of symmetry, again, is just x equals your x coordinate of your vertex. That means in this case we had 1 as our x coordinate of the vertex, so our axis of symmetry is going to be x equals 1. And again, just make sure that you're writing it as an equation, x equals, don't just say 1. Next, we want to figure out if the graph opens upward or downward. Well, going back to what we just did on the previous slide, in order to figure out if it opens upward or downward, we're looking at a. And again, a is the number in front of the parenthesis. So if we come back up top, we're looking at a as being this negative. Well, a can't just be negative, it would be negative 1. So then the question is negative 1 less than 0 or greater than 0? Since negative 1 is negative, that means that negative 1 is less than 0. And if a is less than 0, that means that the graph would be facing downward. From here, also using a, we can then determine if the vertex is a maximum or a minimum. So again, a is still negative 1, which, as we just saw, means that the graph is facing downward, which means that we're going to have a maximum for our vertex. Next, in order to graph, we need to find all of our possible x-intercepts algebraically. So this means walking through it and solving it, not just looking at our calculator and finding the x-intercepts, because we want to make sure to get an exact answer. There are often times when we might get a radical in our answer or some other form of decimal fraction that we want to make sure that we're finding the exact answer. So remember, finding our x-intercepts means that we're setting f of x equal to 0. So I have negative x minus 1 squared plus 9 equals 0. So we want to use our square root property, which means getting this squared piece by itself first. I'm going to move the 9 over, so we have negative x minus 1 squared equals negative 9. And then next we need to get rid of our a, the number that's in front of the parenthesis. Well, again, remember what we said before, that the negative means there's really a negative 1 here. So I'm going to divide both sides by negative 1. So don't forget about that. We need to get rid of that part. So that way we're just left with x minus 1 squared, and then negative 9 divided by negative 1 would be a positive 9. From here we can continue to use our square root property. So if I have x minus 1 squared equals 9, in order to get rid of the square, I would take the square root of both sides. But remember, we are taking that plus or minus square root. So that way we have x minus 1 equals the plus or minus square root of 9. So the square root of 9 would just be 3, and again we need the plus or minus in front. Continuing to solve this, I would move the 1 over, so we have x equals positive 1 plus or minus 3, and since we have whole number here, or we have rational numbers, we can actually evaluate that and find our most simplified form of x. So to have two parts, x equals 1 plus 3 and x equals 1 minus 3. So you have x equal to 4 and x equal to negative 2. So that would be fine in terms of writing your x-intercepts. If you want to write it as an ordered pair, that would mean you'd have two answers of 4, 0 and negative 2, 0. So those are our x-intercepts found algebraically, and you can verify it with your calculator. Your y-intercept should be a little bit easier to find since we're just plugging in 0 for x. So that means we're doing f of 0 equals negative 0 minus 1 squared plus 9. So you do want to evaluate it. It's not necessarily just that plus 9 at the end, as we had in the ax squared plus bx plus c form that Professor Messenger showed. We do want to simplify this using our order of operations. So inside the parentheses we would have a negative 1 squared with the negative still out in front and the plus 9. So again, working through this, we're going to have f of 0 equals, so negative 1 squared on the inside is going to be a positive 1, but that negative 1 is still outside, so we have a negative 1 plus 9, which would then give us an answer of 8. So our y-intercept as an ordered pair would be the point 0, 8. Next, we want to use all the information that we just found to sketch the graph of the function. So first, we want to remember that our vertex was the point 1, 9, so we should plot that first. Then next we had that it was facing downwards. That's going to be important and help check our answer. We had that our x-intercepts were at 4, 0 and negative 2, 0. Then we had that our y-intercept was at 0, 8. And we want to keep that general shape of the parabola. Remember, we said that the vertex was a maximum, so it should be facing downward. So the sketch of the graph would be something like that. Once we have the sketch, then it'll be easier to identify the domain and the range. The domain of your parabola or your quadratic functions are always going to be negative infinity to positive infinity. We don't have any restrictions. And it's actually going to be that way for all of our polynomials. It's going to be, your domain is going to be negative infinity to positive infinity. Your range then, since the function is facing downward, we can see that our smallest y value would be negative infinity. And then your largest y value would be that y coordinate of your vertex. So we went up to 9, which means that we would have a 9, and always using a square bracket since that vertex is going to be included. And again, it should make sense that since our vertex was a maximum, that's going to be the highest point on your graph. So for the range, it would have to stop at that y coordinate.